So we can simplify what we've done to 10 to the power negative 2 because the bases are the same. So we can add the exponents. You have negative 23 plus 21. Negative 23 plus 21. You're just going to get negative 2. So that is it here. Nanometers cube per atom. So therefore, the volume per atom, okay, or the volume of one atom, okay, it's anyhow you want to see it, or anyhow it sticks better with you. The volume per atom or the volume of one atom is what we found here. We can write this as 0.017078. Then we have it here, nanometers cube. Okay, you can add the per atom. That's fine. So this negative 2. You move this 1, 2, 0. So that's what I just wrote here, 0.017078 nanometers cube. Alright, so the third thing we have to do is obtain the radius and the diameter for each atom. Okay, so we found the volume per atom. So we are saying that we know atoms are spherical, okay, and the volume of a sphere is 4/3 pi r cube. Okay, so this is simply the volume of a sphere. So assuming we had a spherical atom and we wanted to find its volume, this will be the formula that we would use under normal circumstances. But now we have the volume of that spherical atom to be what? 0.017078 nanometers cube. So if we have the volume, then we can relate this to this so that we can find the radius here. And once we find the radius, we can easily find the diameter. So we have 4/3 pi r cube to be equal to 0.017078. Let's simplify further to get the radius. So 4 pi r cube is equal to 3 times 0.017078 nanometers cube. We want r to stand alone, so we can divide by 4 pi here, and we can also divide all here by 4 pi. So you have r cube, and since it's r cube, if we want r to stand alone, if we want r to stand alone, meaning we have to find the cube root of r. Okay, so assuming this was r squared, let's say you have a squared equal to b. Let's say you have a squared equal to b. You want a to stand alone. You just take the square root of both sides. So you have a is equal to root of b. So similarly here we have r cubed to be equal to this, and we want r to stand alone. So we take the cube root of both sides. So I'm going to say r is equal to the cube root of 3 times 0.017078 nanometers cube all over 4 pi. So I'll just take my pi to be 3.142 as I've been doing all this while. And we do the calculation here. So the cube root shifts plus the square root sign, you get a cube root. 3 times 0.017078 over 4 times 3.142, and we obtain 0.1597. This cube cancels this, so we have nanometers. Therefore, the radius of a silver atom, okay, a silver atom, because it's silver that we are working with. So silver atom is 0.1597 nanometers. Now it says we should find the diameter of a silver atom as well. We know that diameter is equal to 2 times the radius, right? So if we know the radius, we can easily find the diameter. So that will be 2 times 0.1597 nanometers. So 2 times 0.1597, and then we have the diameter of silver atom to be, or of one silver atom to be 0.3194 nanometers. Alright. Step 4 is saying obtain the number of atoms on the curved surface of the cylinder. Okay, so step 4 is saying you should obtain the number of atoms on the curved surface. So let's say you have a cylinder here. Okay, the cylinder that I drew here. So you have this cylinder here. Once again, it's not drawn to scale. Okay, and then you have the edge of the cylinder to be something like this. Okay, like this pen. Okay, you can see that the edge there, like this part, is this. Okay, so we are assuming that there are atoms here, right? So here there is one atom, one atom, one atom, one atom, one atom, one atom at the edges. Okay, one atom like that. You have the whole diameter, okay, to be given as 20 nanometers. That was what was given to us. Therefore, the radius will be what? Half of 20, which is what? 10 nanometers. That will be the radius of one. That will be the radius of the cylinder, this whole cylinder. Now, if we want to find the distance from here to here, the distance from here, not to the edge, to here, from here to here, we're going to realize that we can simply obtain that by finding the distance between, we can find that by subtracting the diameter of the atoms from the radius. Let me come again. You want to find the distance from here to here, okay? And we know that here is one full atom that's here, like one full atom like this. And the atom has a radius. But when you take the atom from this part, which is here, to this part, which is here, you have gone the whole diameter of the atom. So if you subtract the diameter of the atom from the radius of the whole cylinder, then you are going to get the distance from here to here. Okay, so it's these atoms that are on the curved surface. Once we find this distance, we can find the volume of this distance like this. And if we subtract this volume from the total volume, we will get the volume of this part occupied by the atoms. And once we get the volume of that part, we can find the number of atoms at that part. So that's what we are trying to do. Okay, so let's find the volume here. Okay, for us to find the volume, we know volume is pi r squared, in this case L, right? So to find the volume, we need to find our L, our R value, our radius R value. So that will be 10 nanometers minus the diameter of the atom, which is 0.3194 nanometers. So we do that 10 minus answer, and we have the radius. You can call it the new radius or the radius of the inner circle, anyhow you want to call it. So let's the radius of the inner circle. Anyhow, it should be like how you will understand, to be 9.6806 nanometers. Alright. So we can find the volume, like the volume here. Okay, that's what we are trying to find. If we find that volume, then we will subtract that volume from the whole volume. Then we get the volume of this curved surface here. That's what we are doing. Okay, so the volume of the inner circle, circle or cylinder, anyhow you want to call it, as I said earlier, will be pi r squared L, which is pi times 9.6806 squared times L, which is 100 nanometers, right? So I have my radius here already. So pi is 3.142 times, this is the answer. So the answer squared times 100. Let me go it here. 3.142 times 9.6806 squared times 100. Okay, so it's confirmed. 29,444.944 nanometers cube, because it's volume. So the volume of the inner circle is this. Okay, so to find the volume of the curved surface, we subtract the volume of the inner circle from the volume of the entire cylinder. The volume of the entire cylinder, we found that to be 31420. So we have 31420 minus the volume of the inner circle, that's 2944.944. You can do the subtraction. 31420 minus 2944 point, okay, 29444.944, and we have, let me write it here, 1975.056. So this is the volume of the curved surface. Okay, this is the volume of the curved surface containing the atoms. So this part, this volume, that's what we found. So in the case of the pen, this volume, the curved surface here, this, like the thickness, this part, I hope you get what I'm trying to say. So that is the 1975.056 nanometers cube. All right, now let's find the number of atoms here. So we know the volume of the curved surface, right? And we know the volume of one atom that is in that curved surface. So we can simply find the number of atoms in that curved surface. Let me come again. We know the volume of the curved surface, and we know the volume of one atom that is in the curved surface. So we can simply find the number of atoms in that curved surface. So that will be 1975.056 nanometers cube. And then we found the volume of one atom to be this. Okay, 0.017078 nanometers cube per atoms, right? So when we do the calculation, we have 1975.056 over 0.017078. So we have 115,649.1392 atoms. So therefore, the number of atoms on the curved surface is 115,649.1392 atoms. Okay,